This conference will now be recorded.
Perfect. Good morning, guys. Thank you for joining me today, and I sincerely appreciate it. Okay, so we have completed various important concepts. The first important concept is Python for data science, which we covered basics, advanced, and we also covered GitHub for data science, proper workshop with real-time implementation where we forked, we pulled, we updated, we committed, and we made changes. And machine learning housing project use case is completed successfully. Classification is also successfully completed. In classification, we have completed about binary classification, multi-class classification, multi-output classification, and while learning classification, we understood various aspects of what is F1 score, what is true positive, what is false positive, and what are the decision matrix, confusion matrix, and ROC curve, and various areas of it. Now, all these days, what is happening is without even knowing what is linear regression, what is the formula behind linear regression, you have done a lot of things. In this module, you are going to touch base each and everything of regression process and how the process works and what is the formula, how the formula is interpreted in Python. If you remember, if you recall, sometimes I said, let's park it right now, I'll cover it later. You might have heard this word a lot of times, right? Now, this is that module where I'm going to cover each and everything. When we said about decision function, I said let's park it. I'll discuss it later stages. And I also told you when you asked me something about model parameter, and when you asked me about synthesis, I said let's park it for now. Don't worry, I'll explain later, right? So today we are going to talk about. Today means in this module we are going to talk about various aspects of it. Okay. Theoretically, under the hood concepts I have not covered, but I told you what is what. Okay, so today let's then jump start. What is our agenda in this module? Okay, we are going to talk clearly about linear regression. What is the normal equation in linear regression? And what is the computational complexity you have? For example, one guy can approach linear regression in one way, and other guy can approach linear regression another way. If you are a good data scientist who is concerned about the performance of your workload, then you need to know the computational complexity of the approach you have taken and the approach other guy has taken. That is important. Okay. However, we have implemented linear regression without even knowing how things will work under the hood. Okay. Now, in this module, we are going to understand each and everything of it. After linear regression, we'll be moving into gradient descent. When I say gradient descent, you know gradient descent is used for the validation process. You evaluate your model. In evaluation also, you can follow various process. One is batch gradient descent, stochastic gradient descent, and mini batch gradient descent. So we'll understand the concepts of each and everything, how the batch gradient descent works, how stochastic gradient descent works, and how mini batch gradient descent works. And polynomial regression. Polynomial regression is just one level up the linear regression where you apply the squares of the futures or you scale up the futures further well so the model gives you the best predictions. I have just told you this in a small word, but it's a long story which we will discuss in detail when we come there. Now, learning curves. Learning curves are very important. Before jumping into learning curves, let's understand what are subtopics we have in learning curves. How do you regularize the linear models? What is ridge regression? What is lasso regression? What is elastic net? And what is early stopping? These are also very important. When I say very important, if you don't understand when to stop tuning, if you don't understand when to make a decision, you have understood about ROC curve and area under ROC curve. I have heard a lot of questions when I was telling Anna why this, why are you telling to take only this area of it? That is called decision making. That is called learning curves. In the learning curves, you need to know where to stop further tuning your parameters. If you tune your parameters, either you go too low or either you go too high. But if you properly understand the learning curves and early stopping, you will define, yes, I am doing the things right, and at this point, whatever the prediction it gives, that is the right prediction. That is the importance of learning curves. Perfect. Simple was machine learning learning curves means a curve that says enough. This is the proper best recommended curve where the predictions are at its best. That is what it is. Now, logistic regression. In logistic regression, you will be estimating the probabilities. You will be talking about training and cost functions. Again, you have your normal equation here. This normal equation in linear regression, why you are using it, and the training and cost function is same like you used the cost function linear regression. Perfect. Decision boundaries. When I say decision boundaries, when to decide how things will take to next step. If you are not satisfied with the result, how you can move it to next one. That is decision matrix or decision boundaries. Now, softmax regression. Softmax regression is also same thing, which says the approach you take in the regression process and what are the elements that constitute the softmax regression and its concepts will be covered. This is our agenda. Today we are not starting our agenda. We are entering into the agenda, but from Tuesday we will start practically the whole process of it. I would request everyone to please go ahead and revise or rewind the earlier videos if you are not completed, because I hope you have taken my slides which I have given to you. If you go to this PPTs, data science. This is the first session. I don't think you guys have joined this one. Now, if you see this, in this itself, I explained in the normal equation. Very properly, I have defined what is normal equation. Okay. And I also explained what is the best tips and best practices you have to do while processing your data. If you have joined a little late, then I would request you to at least read the slides. Okay. Here we have explained what is normal equation, but in this module, which is named as training models, you'll understand the normal equation and you'll also approach the other way of training the model in linear regression, and you'll decide which one would do the best. Okay. So first of all, before jumping into this concept, I want to understand, is the journey of this module clear for everyone? Is the journey of this model clear to everyone? Are you able to correlate that at that point in time I said, let's leave it for now, we'll cover later. That things will be covered in this module. Whatever the confusions that was arise to you when we were talking few things, I believe those will be covered and cleared in this module. Are you clear to this point, everyone? Perfect. That's good. Now, let's understand what's here for you. When I say what is here for you, in this module, what are you going to learn? How this module is going to benefit you? Now, all these days, we have treated machine learning models and their training algorithms mostly like black boxes. When I say black boxes, we didn't even mind to go and understand the formula, the implementation of it under the hood, and we just applied the formulas. Like that, we did random forest, we did linear regression, and we also implemented stochastic gradient descent, and we applied some binary classifiers, and we also applied some random classifiers. We really didn't know what is left, right, front, back, under the hood, anything. Now, you might have surprised how much you can do without knowing anything what's under the hood. But practically, Having a good understanding of how things works can help you quickly home in on appropriate models, the right training model to use, and a good set of hyperparameters for your task. When I say hyperparameters again, folks, just recall hyperparameters can be the parameters which you give to your model so that can fine tune your features and estimators so that features and estimators give you the best predictions. You must be aware of that. Now, the benefit you get understanding what's under the hood will help you to debug the issues and perform error analysis more efficiently. If you recall my yesterday's class, when I was discussing with you about multi-class classification, I told you about error analysis. In the error analysis, what did I do? Initially, I got a confusion matrix. Confusion matrix has given me a big matrix which I was not able to find out anything. Later, I have plotted the confusion matrix and that gave me some picture that 8, 9 columns and 8, 9 rows are too dark such that 8 and 9 are more confused with 5. How do I know it? I know it because confusion matrix is best fitted for classification. That also you just approached. But why did you approach with confusion matrix and why you have not taken anything else is very important. That kind of decision making and that kind of approach will be covered in this module. Now, most of the topics in this module will be essential in understanding, building, and training neural networks. We are slowly stepping into core concepts. All this while we are only talking about training models. If you understand this module carefully, your fundamental building blocks for understanding, building, and training neural networks is also done. Okay, so that's the priority and importance of this concept. Most of the things will be theoretical in this module, but you need to understand very carefully. Next one, linear regression model. How do you train those methods and how do you make decisions out of these methods? Before I jump, are you okay with this slide? Is everything clear till this point? Okay, guys, I won't keep on asking, but if you are stuck, just type a message and drop it off. Okay. Now, linear regression. So you applied linear regression, you fit the model, you optimize the model, you evaluated it, you did a cross validation. Perfect. Now, there are two different ways to train a linear regression. The first one is using a direct closed form equation that directly computes the model's parameter and it fits the best model with the training set. And other one is the iterative optimization approach called gradient descent. This gradient descent, what it does is it will tweak the model's parameters to minimize the cost function. When I say cost function, guys, the word cost function is new for you, but simply cost function is nothing but it is trying to make some changes at one point in your training the model so the model performs well in performance. One second, guys, I'm going to stop the recording. Give me 1 minute.
This conference will now be recorded.
Okay, so when we have applied the linear regression model, we have directly fitted, transformed, evaluated, and then cross-validated. But linear regression, you have different approaches to take. First one is a closed form equation. This closed form equation will simply directly computes the model parameters. When I say model parameters, again you need to understand like Python programming, the way you give arguments for your function to take inputs and do the work. The parameters, the model parameters is nothing but trying to come to an edge with best estimators and best features that will give you best predictions. So the closed form will directly compute the model parameters that gives a fit best model. Forget about the link which I have pasted. We'll talk about the link in next 2 minutes, but understand the other approach you have. The other approach is nothing but gradient descent approach. This approach will gradually tweak the model's parameters to minimize the cost function. Again, Try to understand the difference between there and here. There, it is directly computing the model's parameter, fitting the best performance. Here, it is tweaking the model's parameter such that it minimizes the cost function. Now, there are two questions that arises for you. First one is, what the heck is model parameter and what the heck is the cost function? Now, in this process, eventually it will try to converge to the same set of parameters as the first method. The way how first method is trying to take the best model parameters, the GSD also does the same thing, but GSD tweaks the models whenever possible. Okay, now I have a link for you, and this link will show you what exactly does the model parameter does. Let me tell you that, because if you don't understand this, the whole module will be a kind of confusion. Give me 1 second, okay, folks. Are you clear on this slide? Do you have any questions, guys? Sorry, I think it's here. Now, see, an equation is said to be closed form solution if it solves a given problem in terms of functions and mathematical operations from a given accepted set. When I say set, that is your data set. When I say your data set, it is your training set. When I say training set, within the training set, you also have your evaluation set. Okay, perfect. So closed form equation is nothing but it is a solution working on a functions and mathematical operations. Now, why the heck mathematical operations came into picture is nothing but we are going to cover in next slide. Perfect. Now, for example, an infinite sum would generally not be considered as a closed form. Why? Infinite sum means it's keep on summing up. There is never an end for that. However, the choice of what to call closed form and what not is rather arbitrary, since a new closed form function could simply be defined in terms of the infinite sum. In any case, if you are going to approach a model that keeps on running, that has no end for the process of learning, then that is an arbitrary decision you need to make whether to use the closed form or GSD form. Okay, hope this is very understandable way. Perfect. Now let's understand about next statement. In mathematics, an expression is said to be a closed form expression if it can be expressed analytically in terms of a finite number of certain well-known functions. Typically, these well-known functions are defined to be elementary functions like constants, variable x, elementary operations with roots, exponents, and algorithms. Now, often problems are said to be tractable if they can be solved in terms of closed form expressions. This is the normal mathematical way of telling a closed form, and this one is the proper logical definition of closed form. Now, why this guy said in terms of functions and mathematical operations from a given general accepted set, because the reason why he said that is this one. This is nothing but one of the mathematical operation which takes a values for each of the variable and then starts implementing that formula. Are you clear with what is the closed form? Any questions? Guys, in this journey, there are a lot of new things comes in your way. You need to closely decode each of the small terms and move on. When you sit in front of a technical panel, they may ask you, do you know what is a closed form? They may ask you, what is a model parameter? Or how did you tweak the model parameters in your work environment? This kind of questions will be asked. So you must be very careful. Okay. Now, clear with this slide, everyone? I hope that's clear. If you have questions, please ask me. Now, so you know that the closed form is all about your mathematical operations. Now, let's understand the mathematical operations that are implemented in linear regression. Now, a linear regression or a linear model makes a prediction by simply computing the weighted sum of input features plus a constant term called bias term. This bias term is the intercept term. I'll repeat, do not confuse, concentrate, focus. A linear model makes a prediction by simply computing the weighted sum of input features plus a constant called bias term. Means if we have set of features, your linear regression will start summing up the weights of the input features and then a constant that is called as intercept term. This intercept term is the one that keeps on changing based upon your model's iterations or the model's performance tweaks. Now, let's understand the formula here. One second, guys, please focus. This is very, very important. In this module, if you understand everything, your neural networks fundamentals will be strong. Now, what is this y? Y is a predicted value. What are you going to predict is referred in terms of y. N is number of features. Okay. N is number of features mean this bit. If you have 100 features, this theta n into xn will run 100 times. If we have 200 features, theta n into xn will run 200 times. Now when I say feature, again guys, if you remember carefully, the best model parameter is nothing but the estimators and features. If you remember carefully, features are nothing but when you experiment the attribute combinations, you will come to understanding what are the best features in this case for me. For use case 1, the features can be X and Y. For use case 2, the features can be Y and Z. For use case 3, features can be A and B. Like that, with the number of features you have, the formula will have theta n into xn. Now, x is the ith future value. Okay. When I say ith future value, all you need to understand is, for example, you know it's an iteration process. If you have 10 features, your model will be trained on each of the feature. When it came to ith feature, the value that came when it trained the ith feature is nothing but x of I. Okay, perfect. Hope you understood that. Now, theta j. Theta j means theta j is jth model parameter. Now, what the heck is ith feature value and what the heck is jth model parameter? Okay, ith future value is nothing but your futures output when the model is trained or applying a transformation on it. Jth model parameter means after completing the features transformation or features fit or something, the model parameter is the one that decides, do I have to make further iterations so performance will be obtained, or am I fine at this point evaluating the existing performance I have given? That is called theta of j, the jth model parameter. Model parameter is again nothing but the way you have arguments given to your functions. The parameters are the one that gives the best estimators for you. Perfect. Now, this theta j will also have the bias terms like theta 1, theta 2, and theta n, which is nothing but this one, this one, this one, this one. Okay. Now, this can be written more consciously using vectorized form. This vectorized form is nothing but this bit. So, this formula number 1, this formula number 2, both are same. Do not worry about it. This one is represented in a vectorized form like this. When I say vectorized form, we have covered about vectors, transpose of vectors, and dot of vectors in our advanced Python. If you are confused about that, please kindly go ahead and refer to that and come back to me. Are you clear on this linear regression formula? Kavi, are you clear? Did you understand what I'm saying? Guys, people talk a lot that you need to know mathematics, you need to know statistics, you need to know probabilities about machine learning. We are now dealing with statistics, mathematics, and probability. All these days, you have just implemented the whole flow without even knowing what it is doing. I repeat this statement, but the reason I repeat it is we need to get how things work under the hood. Okay? If you understand this slide also, then this is what I have for today. As I told, today's session will be short because I didn't have time for preparing slides, and while I was preparing this one also, my little one didn't let me do it. So that's the thing, guys. So tomorrow I'll upload another video, and yesterday's video I think I have uploaded it. Let me quickly check. Please go through all the slides if you have not completed. It's very important. We are almost there. We are just at the edge of delivering what we are supposed to do. Do not miss the spirit. Erase all the drawings. My meetings, meeting history. Yeah, I think I already downloaded it. I'll upload it, guys. I'll upload it today. Don't worry. Okay. So this is all I have for today. Today's class is just an intro on what is going to be for the next week for us. We are going to complete this module by Friday or Saturday. I'll make all the slides over the weekend properly, and so we can discuss and debate around. But weekends workshop is very, very important. That is going to be one of the value add that you could do for yourselves. So please be prepared and come to the workshop. I'll see you on Sunday. Tomorrow you need not have to attend the online session, but out of interest, I'm going to upload few videos in the YouTube, which will help you a lot. Okay, that's all I have. Sunday workshop, please don't forget. We'll catch up by 9. I'll go and get the fob and keys today itself. Okay, thank you guys. Have a great weekend. Enjoy your work.